Hello everybody, this is problem 6-23 in your book, and we will do this one as an example for the class. And they are asking us to find, I believe it is, determine the force in members DC, HC, and HI of the truss, and state if the members are in tension or in compression. So DC, HC, and HI. So on my figure here, we are looking for, let's do it in red, this member, and this member. So remember, in the lecture we talked about being able to cut a truss, and you can cut up to 3 members. So I'm going to cut this truss right here. So you notice I highlight them in red and then I cut them. That's going to be where I cut my truss. So I can draw the free body diagram of this bottom piece, or I can draw the free body diagram of this upper piece. Now one thing I need to look at is I am going to have a reaction force here and a reaction force here. I'm also going to have a reaction force here. So I'm going to have Fy, and I will have Ax and Ay. So I'm going to have to solve for one of the reaction forces. So I am actually going to do the top left section is what I'm going to solve for. So I need to solve for Fy. So I am going to sum my moment about point A is equal to 0. So if I'm summing my moment here, I will be able to find Fy. So when I do this, sum of my moment about point A, I get negative Fy times 4 meters plus 40 kilonewtons times 2 meters plus 30 kilonewtons times 3 meters plus 40 kilonewtons times 1.5 meters is all equal to 0. So plugging this in my calculator, I get that Fy is equal to a positive 57.5 kilonewtons. So this is 57.5 kilonewtons. So I'm going to do my best here. So I'm actually going to pause the video and then I'm going to draw my free body diagram, and then I will come back to the video. So why don't you do the same, and then we'll come back. Okay, so here is my free body diagram, and what I'm going to do first is I'm going to solve for theta. So theta is going to be the arctangent of 2 over 1.5. So theta comes out to be 53.13 degrees. Now I can sum my moment about point D. And now why do I choose point D? So I come up here and I look at this one. Well, right away it takes out the 50 kilonewtons. I don't have to worry about that. I don't have to worry about DC because it's also going through that point. Also HI is going through that point, so I can solve for just HC by summing my moment at point D. So by doing this, I have 40 kilonewtons, 57.5 kilonewtons, and HI. So summing our moment about point D, I had 40 kilonewtons times 2 meters. So 40 kilonewtons times 2 meters. That's going to be positive minus 57.5 kilonewtons. Now I've got my reaction force, and that's going to be times 4 meters. And then what I'm solving for, HC times 1.5 meters, is all equal to 0. So we get that HC is 100 kilonewtons in tension. If I sum my forces in the X is equal to 0. Now I have my HC. Now I can solve for my DC. If I sum my forces in the X, those are my only two in the X. So I can look at those two, which I would have 100 kilonewtons plus BC times the sine of 53.13, and that's in compression. I'm sorry, got ahead of myself there, is equal to 0, BC is 125 kilonewtons, and that's in compression. And then I sum my forces in the Y. The only thing I have left is my HI here. So if I sum my forces in the Y, I get 57.5 kilonewtons, which was here, minus 40 kilonewtons, minus 50 kilonewtons, minus HI, minus 125 kilonewtons times the cosine of 53.13 is all equal to 0. So we say HI is equal to 42.5 kilonewtons, and that is in tension. So we have all three that we were solving for, and since I asked you guys to highlight your answers, I'm highlighting my answers. So if there's any questions on that, on this problem, let me know. Again, I will upload my solution as well so that you guys can take a look at that. Alright, thank you.